All right, this is Unit 1 Review Day 2. Talked about piecewise functions, transformations, line of best fit, and vertex form of a quadratic function. So this is the second day of Unit 1 review. So with Unit 1 with piecewise functions, we had different functions and plugging them in and all of that good stuff. Now, mine didn't print out very well, so I'm just going to rewrite what it says. So that says 2x minus 5 if x is less than or equal to negative 4. X squared if negative 4 is less than x, which is less than or equal to 6. And then x divided by 2 if x or 6 is less than x. All right, so that's what that says in case y'all's printout came out like mine. So it tells me to find f of 6 and f of 12. So with f of 6, we have to say, okay, is 6 less than or equal to negative 4? No. Is 6 between negative 4 and positive 6? Yes. Now here's where you have to be careful. You have to check and say that this is less than or equal to 6, which it is. Of course, 6 is equal to 6. So that means we use this one and not the next one because this one doesn't have the equal to part of that function. So we're going to plug this into x squared. So f of 6 becomes 6 squared, which is equal to 36. So f of 6 is 36. And then f of 12, so we say, okay, is 12 less than or equal to negative 4? No. Is it between negative 4 and 6? No. Is it greater than 6? Yes. So that means f of 12, we plug into the bottom function, which is 12 divided by 2, which gives us 6. So that's how we did piecewise functions. I'm not going to make you graph on any of the review like we did in class. And then we talked about transformations pretty much the whole semester while we were in class together. Remember, when it's left and right, that's with x, and usually it is in parentheses. And so remember, if it's a positive, that means you're going to the left. And if it's a negative, that means you're going to the right. So like, for example, you have x minus 2 squared. That means I'm going right to, and notice it's in parentheses with x. That x squared is on the outside part. Another example of left and right is like, for example, when you have absolute value of x plus 3. It doesn't have the parentheses there, but it is inside the absolute value bars with the x. So that means that we're going left 3. Okay, so then there was up and down. And remember, up and down is always at the end of the function. And so if it's positive, that means we're going up. If it's negative, that means we're going down. So like, for example, you could have x squared minus 2. Now notice it looks like it's with x, but it's not because it's at the end. It's not in parentheses like this one was. So that means we're going down 2. And then, for example, x square root of x plus 3. Notice again, it's not in that square root with x. It's at the end of the function. So that means our graph is moving up 3. Okay. Then the next one we had was vertical stretch and compression, and that's always multiplied at the beginning. So it's not with x, it's if it's a vertical stretch or compression. So like, for example, 3x squared minus 1, okay? Even though the 3 is with the x here, it's not put in parentheses around the whole function. No, wait, I told that wrong. 3, then x squared, sorry. This is a vertical stretch because it is directly in front of the whole function, not with x. So that means it is a vertical stretch by 3. And I put VS for a vertical stretch. Okay? So for example, say it was 1/2 absolute value of x. Again, it's not with x, it's in the very, very front of my function. So that means that's a vertical compression by 1/2. Remember, if it's a fraction, it's always a compression. If it's a stretch, it's going to be a whole number. And then with horizontal stretch and compression, that's where a lot of people had issues because it's always multiplied with x. And before you can ever say whether it's a stretch or compression, you must always remember to flip the fraction. This is where y'all had issues with vertical and horizontal, because you would have issues with which one you flip. It's always horizontal that you flip. So like, for example, 2x squared. Notice there's a difference between this function and this one. The 3 is in the very front. It's not technically with x, versus 2x squared is right there with x. Another way to have seen that is if you put it in parentheses with the 2 and then x squared. So that would be a horizontal compression, because if you take 2 and flip it, it becomes 1/2. So that's a horizontal compression by 1/2. Okay, and if I have square root of 1/3 x, when I flip it, 1/3 becomes 3. So that means that's a horizontal stretch by 3. Okay, so for example, I've got 11 through 13 where we've got the equations and we want to describe the transformations that are happening there. So like, for example, 2x squared. Notice this one and number 11, or 11 and this one are very similar, okay? It's not in parentheses with my x, okay? It's in the very front of my function. So that means that this is a vertical stretch by 2, because it's in the very front of my function. It's not with x, okay? And then the -5 is at the very end, so that means I'm going down 5. Okay? Number 12 says absolute value of x minus 3, which means that it's in the absolute value bars with x. And because it's subtraction, that means we're going right 3. And then we have that +1 at the end, so that means I'm going up 1. Okay? And then the last one, 3 square root of 2x. The 3 is out in the very front, which means that that is a vertical stretch by 3. And then the 2 is with my x. So that means the first thing I have to do is flip my fraction. So 2 becomes 1/2. So that means that's a horizontal compression by 1/2. Okay. So then that's our transformations that we talked about. And then we talked about finding line of best fit using finite differences. And remember, finite differences is when you take your y values and you subtract them, and however many times you have to subtract to get a constant is whether it determines whether it's a linear, quadratic, cubic, or then if all else fails, that's when it becomes an exponential. So for example, we're going to take -55 and subtract -27, and that gives me -28, and we keep on subtracting. And I've already got these answers written, so I'm kind of skipping over all the work there. So when I subtract all my y values, -4, -8, and -18, okay? And notice none of those functions are, or none of those values are constant. So that means I have to subtract again. Now, if all of these had been the same, that would have made it a linear function, because it only took me one time to subtract. Okay, so then we subtract again. -28 minus -14 gives me -14. And then -8. And then -2. And then +4. And then +10. Now again, I still didn't end up with a constant. Now if it had become constant the second time, that would have been quadratic. So now we have to subtract one more time. So -14 minus -8 is -6. -8 minus -2 is -6. -2 minus 4 is -6, and 4 minus 10 is -6. So this time, I got my constants. All of them are -6s, and that means it's a cubic function, because I had to subtract 3 times in order for it to become constant. So that's a cubic function. And we talked about in our class how to find a line of best fit using the table and your calculator and all that. All I want you to be able to tell me is what the parent function is. All right, so then for our next example, we subtract again. So 0 minus -2 is 2. -2 minus -2 is 0. -2 minus 0 is -2. 0 minus 4 is -4. And then 4 minus 10 is -6. So again, still didn't become the same, so it's not linear. So then we try again. 2 minus 0 is 2. 0 minus -2 is 2. And then 2, and then 2. Which means that this is a quadratic, because I got my constant function after subtracting twice. Okay, so then the last thing to talk about is the vertex form of a function. Okay, so that's where we have x squared plus 6x minus 5. And the first step is to, well, we first have to set it equal to 0. I didn't give you the 0 on accident, but the first thing is to set it equal to 0. Okay, then we want to, 1, move the c value to the other side. And you don't just take this and all of a sudden put negative 5 on the other side. Remember, in order to do that, you have to take the opposite to both sides. So that means I'm going to add 5 to both sides. So that's going to give me x squared plus 6x equals 5. Okay. The second step is to take our b value and do b divided by 2 squared and add it to both sides. So our b value here is 6. So that's 6 divided by 2, which is 3. And 3 squared is 9. So that means I'm going to add 9 to both sides. So that's going to become x squared plus 6x plus 9 equals 5 plus 9. Okay. And then we combine our like terms here. So it's going to become x squared plus 6x plus 9 equals 14. Okay. Then step 3 is to factor. And the trick with finding the vertex form is this will always be x plus a number or x minus a number squared. Okay. So it's always what's going to multiply to give me 9 out to give me 6. And it's going to be that same one, the same number twice. So that means the same number that's going to multiply to give me 9 and 6 is 3 and 3. So that's going to become x plus 6, or x plus 3, sorry. X plus 3 squared equals 14. And then the last step is to set it equal to 0. So the way we do that is we subtract 14 to both sides. So that's going to become x plus 3 squared minus 14 equals 0. And that's our vertex form. And remember, the vertex is always the opposite of this number. So my vertex is at -3, and then we keep this number the same. So comma 14. That's my vertex. So the vertex form is this equation, and then the vertex itself is the bottom part. Okay? All right. Number 17, I'm going to change the equation. I don't like that one because it ends up turning into this same equation up here. So I'm going to do 2x squared plus, 2x squared minus 20x plus 12. Okay, now notice this one's a little bit different. Notice that this one was x squared plus 6x minus 5. We didn't have a number out front to deal with. This time we do. All you have to do is take that common number and factor it out. Well, the common number here is 2, and usually it is that very first number. So I'm going to take 2 out of all of these. So my new equation is going to become x squared minus 10x plus 6. Okay, and this is going to be the equation we do these steps with here. Okay, so we're going to set it equal to 0, and the first step was to move the c value to the other side. So we're going to subtract 6 to both sides. So that becomes x squared minus 10x equals -6. Okay, and then the second step is to do our b divided by 2 squared. My b value is -10, so -10 divided by 2 squared. -10 divided by 2 is -5, and -5 squared is 25. So we're going to add 25 to both sides. So it becomes x squared minus 10x plus 25 equals -6 plus 25. All right, I'm going to combine my like terms here. So x squared minus 10x plus 25 is equal to 19. And then we factor. And remember, it's got to be the same number that multiplies to give me 25 and adds to give me -10. So we know that's going to be 5 and 5, but notice the number has to add to give me -10. So that means it's going to be x minus 5. And so it's going to be negative 5 and negative 5. So x minus 5 squared equals 19. And then the last step is set it equal to 0. So I'm going to subtract 19. So x minus 5 squared minus 19 equals 0. And that's the vertex form of my equation. Okay, so x minus 5 squared minus 19 equals 0, which means that my vertex is at positive 5, negative 19. Because remember, you take the opposite of your x value there. So positive 5, negative 19. All right, so that's the end of the Unit 2 or Unit 1 review day 2 notes. And then the day 2 classwork, in case yours doesn't print out right like mine didn't print out, again, is going to be 5 if x is less than negative 2. This one is 1/2 x minus 6 if negative 2 is less than or equal to x, which is less than or equal to 6. And then negative 2x minus 10 if x is greater than 6. So for 1 through 6, you're going to use this function here, this piecewise function, to graph it. 7 through 9, you're telling me what transformations happen. 10 and 11, you're going to tell me what parent function is. Is it linear, quadratic, cubic, all that good stuff. And then on the last page, number 12 and 13, you're just going to convert it to vertex form and give me the vertex of both functions. Okay? Again, if you have questions, comments, concerns, message me on Remind or comment on any of the Google Classroom. Okay?